Recording started. Thank you, marvellous. I'll check through who's here in a minute as the others are speaking. But let me just share my screen. So I'm Becky Malby. I am from Ilkley Clean Rivers campaign. And oops, that's great. And I'm going to share a little bit about the sort of why it matters to do water testing in as part of a campaign. And you might know, of those of you that are on our mailing list, if you're not on our mailing list or want to be on it, which is general updates on politics and life, including news, then do email me and let me know. But you'll know that we've been successful in Ilkley at getting very significant funding to clean up our river. So we're getting not only a mega pipe put in at the moment, but they are going to double the capacity of our sewage treatment works. We're in that rapid accelerator process at the moment for that, to improve our tertiary treatment and to clean up some of the CSOs. So there's work upstream at Addingham where Rick lives, there's work in our major, downstream at the CSOs, and there's work on the major sewer. It is absolutely huge. And it's thanks to this process. So I'm going to go through, and it is relentless. I think, Sheila, you were emailing me yesterday saying, oh my God, it takes over your whole life, this, doesn't it? It really does, because you get knocked back so often. And the reason why I think we're as successful as we are, or have been, is it's not just because it's a very pretty place and it's fantastic for media, but because we have irrefutable data, and it's really hard to work away from it. The reason why clean rivers is at 68% of this country thinks our government is not handling this well. It is an election issue. It's cross-party, because this is not a party political issue. The issue for our cleaning up our rivers is that everybody has failed it so far, and we have to get back on top of it. And so it doesn't fit neatly into being siphoned off as the sort of loony left or the far right or somewhere in the middle. We are across this group, I would imagine, politically very diverse. And so it's our absolute passion for rivers and for river quality that really matters here. And the reason why John and Woodleigh Impact have got involved, because it's been the voice of local people and local campaign groups that has turned this. I know we have Fergal, he's marvellous. He's fantastic at articulating, he's great for the media, but he doesn't have hundreds of people behind him individually. We have, each of our campaign groups, hundreds of people behind us, all of whom vote. And so there's a massive amount of support for local groups who are managing to turn the tide. So it's great to have celebrities, it's fantastic to have that sort of press. It really, really helps. But it's this mixture of fantastic people like Fergal and then the massive amount of work we're all doing locally that is making the real difference here. And so we've got the regulators and our politicians running a little bit scared at the moment because they have not been able to respond properly. So this is part of a campaign strategy. And that's why Woodleigh is really interested in supporting us. I'll talk to you about, they can talk a bit more about that in a minute. So the first thing I think is, as you're doing this work, when you're thinking about water testing, which is what is it that you really, really want to achieve for your river? Are you clear what your goals are? And are you clear how water testing helps you? And if you're applying for bathing status, and not everybody needs to, and you don't have to, and it's not necessarily right for everybody, if you're doing that, then what is it trying to achieve? And I'll tell you for us what it was. So when we're thinking about our campaign, sorry if any of you have seen this before, we were pretty clear about some principles for our campaign. The first thing was being really clear on the focus. And we set 3 priorities for Ilkley, and we have relentlessly pursued those. And the 3 priorities are to stop Yorkshire Water pumping solids into the river, to stop sewage discharge outside exceptional conditions, storm overflow being the word. So really clear, the legislation says, I think I've emailed loads of you, and I did a briefing to MPs a couple of weeks ago, just setting out the legislation says exceptional circumstances. And the third thing was to get our plant upgraded to cope with our population and our climate. So our increase in pollution in Ilkley. I'm not saying you need to pinch those, but you need to find some very clear focus to your campaign, because what you'll find is you get campaign drift. You start getting involved in all sorts of things that aren't relevant. And what's really helpful for Rick when he's in the environment, when he's working in Addingham as the environment group, or when he's working for iWharf with Yorkshire Water and the agencies on testing the whole, that is different from the Ilkley Clean River Group campaign. So we're clear what we are, and when we partner with others, we're clear what we're doing with them. So what are we trying to achieve in Ilkley? We know that if we achieve these things, we are expecting to be able to secure a clean river. So that's the first thing, which is make sure you've got a focus. The second thing is data, to say what is going on now. what is the current situation? So for us, it was numbers of raw sewage discharges. We don't call them spills, and we don't call them storm overflows. We don't call them CSOs. We call them raw sewage discharges. Differentiate that from treated sewage, because our treated sewage is also polluting our river, as Rick very absolutely showed us as part of the data work. And it's the data work that gets you this picture. So you come in with a set of assumptions. Our assumption was it was all the untreated sewage that was polluting our river, and Rick's testing showed it was also the treated sewage that was polluting the river. So the testing, the data gets a picture of what is actually happening, and it's a mixture of water testing, quality, how much pollution is there and how much of it's from sewage, and the number of times that that is going into the river and the impact that it has. So be really clear, the data helps you irrefutably say, this is the picture now. Do we think this is okay? 140 plus discharges of raw sewage in Ilkley. Do we think that's okay? No. Is that within anything like the parameters that the Environment Agency sets as okay for our river? No. Is it breaching its consent at the sewage treatment works? As it turns out, it's not. Hang on, is it breaching the legislation? Yes. So you start saying, this is what it is. And look, here it is. It's in breach of this legislation, but it's not in breach of the Environmental Agency rules. That's bonkers. And that means that you can mobilize, and what we've put in here is turn up the heat. So if you have data about what's going on around here and a massive amount of support from local people, so when we're thinking about what's really happening, how do we ensure that we engage the diversity? We have our town, our local politicians, our leaders saying, "What do you know? This is what's going on around here. Do you know it's 140 times a year? Do you realize that this level of E. coli? Do you realize that this many kids were sick? Do you realize that apparently it's legal here, but it's not legal there?" Local people get absolutely outraged and really passionate about this. They just don't like it. They think it's horrible. So mobilizing local people makes a lot of difference. We have, I think, within our town meetings, we usually have 100 to 200 people turn up, and we have 500 people involved in our mailing list, and we have about 50 volunteers on a regular basis. So it's good to have those folks involved, including at every level: Bradford Council, Ilkley Council, our MP. We have a few arguments with our MP. You might have seen him in the press. He's not our biggest fan at the moment. We don't like the way he voted. So just to get a sense of that, it is all about ensuring that we have local people saying stuff that matters to them locally. And then the next thing is, how do you hold them to account using that data, applying pressure, making it visible? Your press is absolutely hot. It's such a high press issue at the moment. So using the data about, not just the number of raw sewage discharges, but also the data that we had from Rick that said, actually, in dry conditions, this bit of the river is okay. Oh my God, that bit is so not okay. And that's when lots of people go. And pictures, of raw sewage on the riverbank. You use photos, you use whatever you can. So the data, not just the citizen science, but your data, i.e. the photographs you take, the stories that you collect, all of that is an important part of saying this is what's happening now, and using that again and again and again repeatedly to advance your campaign. And the next thing is that you have to collaborate. So there are times when we are adversarial with Yorkshire Water or with Ofwat, and there are times when we're collaborating. So Rick, as our chief scientist in all the stuff around citizen science, not only has he been working with us in Ilkley River group about the river at Ilkley, but also saying, let's have a look up to where are all the sources of pollution? Where is it coming from? How much of it is agriculture? How much of it is human sewage? Because we wanted to show, we knew they would say it's agriculture and they'll try and divert it off the sewage treatment works because it's so expensive. They want someone else to take the blame. And that was what was phenomenal about having Rick's work, is he could demonstrate what was human, what was agriculture, and what's the real problem here. The real problem in our river is sewage. And we could say it in an uncontestable way, which is really helpful. But Rick's work about doing the whole of the wharf meant that from the source to the end, we have testing once a year, or last 2 years, that demonstrates all the peaks and troughs, and you can see where all the major pollutions are. No surprise it's sewage treatment works. Why would we have to show that? Sadly, we do. So for that one, we do collaborate with Adim Environment Group, with the Rivers Trust, with Yorkshire Water, and with the Environment Agency. Sometimes in our strategy for this, we've had to say, there's a pollution spike here. Where is it? And we've had to go find it. And that, again, is a collaborative process. And the process we're in now around this accelerated investment in Ilkley, we're now collaborating with Yorkshire Water as their stakeholders to try and ensure that we get the funding from either Yorkshire Water or from Ofwat to secure the what we wanted to see. So there's this sort of data, you know, how many raw sewages, there's our clear objectives, what water testing helps you achieve. So Rick will talk you through this, but it's really important that you have a hypothesis about what is it that water testing is going to do for you. So it could be that your hypothesis is about the sewage pollution at your river at a point. Maybe at the point at which you are trying to apply for bathing status. We applied, for those of you who've been involved in our bathing status seminars, we applied for a 1 mile stretch in sections and we were awarded for the whole. It was really problematic originally because they said it was just 1 point. What's been really helpful is the fact that we have got apparently the award for the application, which was for the 1 mile stretch. And that meant we could go after this accelerator money from Ofwat for the whole stretch, including our sewage works. So whilst they were a bit reluctant, and it took us nearly 2 years to argue that we had applied for it and got this whole stretch, the reality was that the agencies were trying to avoid that. The fact is that's what's got us the investment across the whole stretch. So you have to be really persistent. Sheila knows this. You just have to keep on and on over the same things. So what is it you're trying to understand with your citizen science testing? Are you trying to understand where it is people use the river and what is the level of the pollution and what are the causes of that pollution? Agriculture, human, which CSOs? Is it from those particular small combined sewage outflows? Is it from the main storm overflows? Is it from the sewage treatment works? What's causing the pollution? And on the whole, we want to be able to tell that story to our MPs, to our public, to the media. We need to have, for the media. Actually, do you know what? It turns out, this is a nice one from us, in 8 millimeters of rain in Ilkley, the raw sewage is discharged into the river when it's 8 millimeters rain. That is not exceptional. That is not even heavy rainfall. That is light drizzle here in Ilkley. Now, that's fabulous data, isn't it? So trying to combine what you know about the quality of the water, and that generates, and we add in, a water quality that means that it's 40 times over the limit of the bathing status quality water, so 900 CFUs. So we can say, not only it's this many times, but in this amount of rain, and it's 40 times or 30 times or 20 times or whatever it is in yours, 20 times the level that it is safe for your child to put their big toe in the water. Can you see how you build the story? So you're using the data to build a picture and a story for the public and for the media and for yourselves. So you want to show the impact, and you want to show the impact in a way that you can describe. So Rick's data will give you, the amount of pollution, and you can work out the story that goes alongside it. You might want to hypothesis about this stretch of the river. You might say people use this whole thing. I want to see how it changes over time or over this stretch. I want to know, are there any parts of my river where actually it's less polluted and I could let my kids stick their big toe in? Or is it all polluted at this level all the time? Or is it just sometimes? Or is it okay when it's dry? We were finding our upstream section, if it didn't rain, that was sort of okay. Downstream of the sewage works, terrible. So getting this picture right really matters. What's the stretch look like? Or you might want to investigate a particular pollution source. You might want to know how much of it is your sewage works or how much of it is the CSO, or are there some of your combined sewage outflows that are worse than others? And if you knew that, your water company might be able to fix that. And we think we found a boulder, didn't we, Rick, in a stream, in one of the places that was polluting the river. And it was through Rick's testing, our fishermen and our local people looking and saying, there's something awful happening here. Let's have a look. Rick, test it. Let's have a look at the testing. What's the testing tell us? Yorkshire Water, did you know that there was this level of pollution coming from this source? What could we do about it? What intelligence can we bring to bear to find out what the solutions are? So you've got quite a range of hypotheses you might be using. But overall, all of these are about trying to find out what's really going on around here. So I'm going to stop sharing this one at the beginning, just to get a sense of this is where we're at with the campaign as it is. How do you begin to use the hypothesis? Are we okay for the moment? Getting the hang of this? Okay. I'll answer some questions in the chat, but what I was going to do next is sort of just carry on through for a bit longer with Rick explaining the how you test it. Is there any particular questions before we do that, just on the campaigning? Anybody got, and just shake your hand, put a thingy up, because we've got two screens, or are you okay on the campaign? Everyone got their strategies clear? Great. Rick, do you want me to share the slides? Okay, so let me just get the right slides for you, and I'll share the how to do it, which is absolutely fascinating and marvelous. Here we go. Is that all right?
Oh, that looks good. Yeah.
Perfect, perfect. And I'll have a quick look at the chat whilst you're talking, and you tell me when you want to.
Do you want to pop it onto full screen?
I will do that. How's that?
Yeah, that's good to me.
And then
Can everybody hear me?
Yeah.
Yeah.
If I'm
okay. Okay, right. Thanks, Becky. That's a great introduction. So that's just the title slide, and just acknowledge that Malcolm Secret, who's actually on the call, works very closely with us on the citizen science work on the River Wharfe. Next slide. So, as Becky said, the key thing is, what do we want to know? And yeah, next slide. Let's come back. This one, yeah, thank you. Yeah, define the questions. Just very simple questions, really. What do you want to know? Do you want to know what the concentration of fecal bacteria is at a particular site? It could be probably a recreational site, or a site that's POP is used by local people. And the other critical question, of course, is where does the pollution come from? Where do the fecal bacteria come from? And again, you need to know your local geography and work out where the potential sources are. Next one, please. So these are the two particular types of bacteria that we're interested in, that the Environment Agency tests for when they're carrying out their statutory duties to test for fecal bacteria at designated sites. This is E. coli, Escherichia coli. This is what this one looks like in a scanning electron microscope image. And the next one is, next slide, is Enterococcus faecalis. This particular one here, it's usually called intestinal enterococci, a number of different species, but this is a picture of Enterococcus faecalis. And this is what it's all about in terms of designated bathing water status. It started off with the EU Bathing Water Directive, but that's now in UK law. And so this is what DEFRA and the Environment Agency and Yorkshire Water and the other water companies are concerned about. And it's these levels of bacterial concentration, the E. coli and the intestinal enterococci, whether you're designated bathing water is excellent quality, good quality, or sufficient. And these numbers are percentiles. Don't need to go into that, but that's a calculation based upon lots of sampling through the season. And for example, in the 95 percentile for excellent or good quality, you're essentially looking for 95% of the time. You don't want your concentrations to be exceeding that particular value. Now, where we're dealing with just small numbers of samples, we're not actually doing statutory sampling as the Environment Agency are required to do. All we use locally, and I think it's quite a good guide, are these figures that I've highlighted in the middle for good quality. You could use a sufficient one either. I've just put good quality there because that's a nice round figure of 1,000 for E. coli and 400 for intestinal enterococci. And so we're saying, well, you know, if it's less than 1,000 on any one occasion, then maybe it's not too bad. If it's more than 1,000, then it's something you want to get really interested in and concerned about. Next one, please, Becky. So one of the questions, in fact, and this is a question that's related to strategy and funding. Do you need to actually do both? And we've done both, and but normally we now just use E. coli because there's a pretty decent relationship between E. coli and intestinal enterococci. You can see on the left there the data for the River Wharfe from the headwaters down to the confluence with the River Ouse, and the blue is the E. coli and the red is the IE. And you can see that the E. coli is always more except for one site there, more than the IE. And on the right-hand side, you can see the relationship between the two. So there's a pretty good relationship there. It's about 2 or 3 to 1 E. coli to IE.
Rick,
So
would you just say how you know it's humans, not animals?
that will come later, I
Perfect.
think. Yeah,
Okay.
yeah. In this particular case, we don't know that. Yeah. So the question then is, where are the sources? We've talked about this already. Becky's mentioned this. We do have to consider whether it's a human source coming through sewage treatment works or combined sewer overflows. But there's also private sewage works we need to be aware of. And of course, there are septic tanks in the countryside. But we can get high numbers of fecal bacteria also from especially ruminant livestock, cows, sheep, and wildlife as well. And depending where we are, what the geography of your site is, depends upon the contribution from these two different sources. Right, next one. Have you got something on the screen there that shouldn't be there? Captures and subtitles. I'm getting a funny screen, Becky.
You carry
Yeah,
on
press got it in the press the bottom right hand corner saying got it, and that will get rid of it.
Okay.
Bottom right.
Is that Becky that needs to do that? Yeah. There we go. All right. So looking at the sources, we've mentioned this before. This is the Ilkley storm overflow. And the point here is that this is quite clearly with high concentrations of fecal bacteria, nutrients, and organic matter. But despite the fact that these operate quite frequently, they are operating intermittently, and that's important. Next one. Further downstream, we've got the treated effluent outfall there. You see it looks much cleaner. It's cleaned up with organic matter, but it's still high in nutrient concentration and in fecal bacteria. But the important thing here is that this is actually a continuous, not an intermittent outflow. Next. And then agriculture upstream, if we're in a rural area, it's certainly in Ilkley, and upstream of Ilkley, we've got a lot of agricultural land with sheep and cattle love drinking in the river, as you can see here. And they seem to be programmed, in fact, to raise their tails when they actually touch the water. So if you think about a cow releasing perhaps 40 times a human excreta a day, then in fact, it is possible for agriculture to be an important source of high concentrations of fecal bacteria in the river. Next. So, yes, important thing, we've got to take samples. Those samples need to be analysed in a commercial laboratory, and it's not cheap. So we need to raise funds, and that's something I think that will be obviously discussed in this seminar along with John and Woodleigh Impact. But we need to find a lab to send the samples to. We use this lab called ALS Limited. We need to set up an agreement with that lab to analyze the samples. But we need the funds from somewhere. Next. And then we need to work out where we're going to sample. We need to do that really very carefully using maps. Once you've decided where the sites are probably going to be located, need to carry out a careful recce. Check for permissions. It may be that the best sampling points you need to cross private land. So you need to find who the landowners are and get permissions to trespass. Need to check where you can park cars, particularly if there's more than one car required, because you're taking 2 or 3 or 4 different people along with you. And then fix and record the exact sample location. And this is really very important, because one of the most important things to do is to be going back to the sites time after time and you need to be sampling from exactly the same site each time to make the data comparable. Yeah. And so here in Ilkley, here we have our sample points where we started 2 or 3 years ago. You can see the sewage works there in the middle. and we've got 5 sampling points there. So the one there is upstream. The 2 is actually our main designated bathing water site that the Environment Agency are now sampling. And as you can see, that's situated upstream of the sewage works. And then the red arrows there, one shows the position of the storm overflow, the other shows the position of the final treated effluent outflow. So we've got a sample in between the 2, because one of the things we've been trying to do is to separate out the impact of the storm overflow from the impact of the final treated effluent outfall. So 4 there is downstream of both those outfalls, but it's also a beach area 2 that's part of our designated stretch of river. And you can see that therefore bathing in 2 is going to be quite different in actually exposing yourself to bathing the water in at 4. And then 5 taking downstream. The other thing to point about point 4, and this is actually in the guidelines too, this is situated because it is a bathing water site. It's a beach area there, but the numbers that we get from there are higher than you would perhaps expect, and that's because it's really quite close, as you can see, to the outfall from the sewage works. And at that point 4, the sewage that's being discharged, the effluent that's being discharged, is not fully mixed into the river. It's not fully diluted. And so what we're sampling there is essentially the plume of rather more polluted water than the average water. Now that's important because that's what people are exposed to. But if you're looking for the concentration in the river in general, you need to be downstream at site 5, by which time the water is the sewage is fully mixed into the water, and so concentrations at 5 are always going to be lower than concentrations at 4. Next. And then if we want to, as Becky said earlier on, to look at a long stretch of river, then this is what we call synoptic sampling. We got to look at sources of fecal bacteria, whether it's agriculture or from sewage works, but it's mainly access points and staging, sampling stages all the way down the river to get a picture of the pollution status of the whole river. So this is covering, as you can see, the River Wharfe, which is over 100 kilometers long. And to do this, we needed to sample it all in the one day, actually in the one morning. So we divided it into 5 teams of people there in those different color codings. And we sampled about 50 to 60 sites within a 4-hour period, during which time the river conditions were very similar. So all the data that we acquired were comparable. So if you are wanting to sample a long stretch of river, the important thing is to be able to actually have trained volunteers and to sample quite quickly within the same river conditions. Next, please. And then we need to obviously record our sites very, very carefully. And this is an example of a spreadsheet that's showing the spreadsheet that Malcolm set up for the IWARF project, and just showing the codes of the sites, the type of sites, the lat and longitudes, the grid references, the name of the site. And it's also recorded there in the middle, where to park and the access to the site. And then on the right-hand side, that's the link to the Environment Agency river level gauge, so that you know exactly what the river level is or was at the time of sampling. So setting up a spreadsheet like that, if you're dealing with more than 1 or 2 sites, is actually very important. And Malcolm's put together this really quite useful resources folder that there's links to it from the guidelines that we circulated. And that's a completed spreadsheet, but there's also a template empty spreadsheet that you can download and use as well. Next. And so that's just clicking on that spreadsheet, looking at that particular site using Google Maps. You can see there the sampling point, just in this particular case, downstream from a small village called Kettlewell. Thank you. Next one. And then let's think about the problems of sampling. You might be sampling in different flow conditions. If it's quite low flow, then it's fairly safe and straightforward. But it's really important to sample at all stages of flow. And rivers can be very, very dangerous places. So you really do have to be aware of the risks and do a careful risk assessment. Again, you can download this resource from the resources folder. This is the risk assessment that we put together for the wharf, and what's important is to know about the general risks there, and that's what that particular document shows. But also be very careful about specific sites too. If you have to scramble down a steep bank, for example, what the risks are and what you need to do to actually minimise that risk. So I can't stress the importance of doing careful risk assessment strongly enough. Next. And then another risk is a risk not to yourself necessarily, but to wildlife and to the problem of inadvertently transferring invasive species. And again, it's a problem almost for all rivers in the UK. We've got invasive plant species and invasive animal species like signal crayfish, for example, and plant species, things like Himalayan balsam. So when you're working from one site to another site, then you really must make sure that you check clean and dry, as it shows there, and you don't carry any eggs or seeds on your waders or wellies from one site to another. If you're working on an individual river, then always work from upstream to downstream, in fact, because you're less likely to then spread an organism, an invasive organism, if you do it that way. This is absolutely critical. If you're moving from one stream to another stream, or from one river to another river, it's even more important to check your equipment, because you might be actually taking an invasive organism from a contaminated site to actually a clean site. So that's really important as well. So sampling, use sterile bottles. The lab will provide the sterile bottles. You can take flagons of tap water, because tap water is sterile. We've measured it. Yorkshire water is good drinking water. There's 0 E. coli in it. So you can actually use that for rinsing out your sampling containers. Samples need to be kept cool. And you can use a portable fridge, but it's simplest to have a cool bag and put ice packs in it there to keep the samples between about 2 and 8 degrees centigrade. And the important thing is to make sure that you can get these off to a lab to be analysed within 24 hours. Next. Sampling, 2 or 3 different ways of sampling. If the flows are low and you can get in with waders, or then you can just wade into the flow of the river, and you can see top right hand side there, Steve is actually in a rather deep water. You shouldn't really go if in fact it comes above your knee height, but Steve's an experienced angler there, and he's looking upstream and he's sampling about 6 inches below the water surface. With a sample bottle there. That's one of the bottom right-hand corners, the first one we ever took. So you can see the date there, 29th of April, 2019. Next. But the other way to sample, in fact, if you've got higher flows and it's more difficult of access, either from throwing a bottle in from the side or from a parachute, is to put together this simple throw bottle here, very, very cheaply. It's just strapping a bottle to a rope with a weight on the end, and then the weight will carry the bottle below the water surface, so you can actually fill the bottle. And you can do that from a parapet of a bridge, or you can swing that in from the side, swing it in as far as you can into the flow, full flow of the water, let the lead weight drag the bottle below the water surface, fill it up, and then bring it back in again. Next. And or you can buy a telescopic pole like this one here. This is what the Windermere group are using, and a bucket on the end there. And again, if the pole's long enough, you can take a sample from a parapet, or you can take it from the stream bank or the lake shore. Thanks. Again, just repeating, keep the samples cool between 2 and 8. Absolutely important to double check that you've labeled the bottles correctly, and this is not just the day and the site, but also the time of day, because that's what's needed to check that the samples have arrived at the lab within 24 hours. And then at the lab, depending which company is being used there, the samples need to be registered. There are special forms, and all that information of individual samples need to be entered into the forms, and those forms then get forwarded on with the samples to the lab for analysis.
For those of you that get funding through this scheme, we'll sort this side of it out. We'll commission the labs, and we'll tell you how to do that part if you're successful.
And then just finishing off with sampling, this importance of flow conditions. If it's dry weather, low flow, then the CSOs are not spilling. There's not any fecal bacteria being washed off from the agricultural land. Conditions are usually very good in general, but this is a time at which you can pick up most clearly the impact of the treated effluent, because it's a treated effluent that's flowing all the time and is not being diluted by higher flows. So sampling low.
On this one, sometimes in low flows, we're still seeing what we call dry conditions where CSOs are being discharged.
Yeah, pretty rarely though. Pretty
I'm not
rarely.
talking about you, Rick. I'm talking about across the country. So
yeah,
you might find in your
possible.
area. So it's really good to have people who are walking along the bank and spotting CSO discharges. So if you've got a low flow, dry condition, but the public has spotted it, get in there with your sampling.
Yeah, absolutely, because that should never happen. That should not happen. Yeah.
Yeah, it is illegal. So that's the other thing. Report it.
Next, I think
is that how you're finding the difference between human and
Mark,
animal?
Can we just pop the questions in the chat, Mark? We'll come back to questions in a minute.
Yeah. And so this is the Ilkley again. We see the same sampling sites there, slightly smaller scale. So you see a little bit more stretch of river there. But this is low flow in July 2019. And just looking in the middle there, you can see, well, just the top three numbers, 100, 450, 350. These are pretty good numbers, well below that 1,000 threshold that we mentioned at the beginning. But you see then there's nothing spilling out of point 2 there. That's the storm overflow. But then as you see at Beanlands Island, point 3 there, we jump up 2 orders of magnitude. We go from 350 to 35,000. And so that's what Bikke was mentioning at the beginning, in fact, evidence that it's not just the storm overflows that are a problem, it's the treated effluent. The treated effluents outside designated bathing areas are not treated to remove fecal bacteria. So downstream of any sewage treatment works, you have high concentrations from the treated effluent. But then if you've got heavy rain, persistent rain, in theory at least, it might be before you have heavy and persistent rainfall, then the CSOs will start discharging. And these, of course, will have high concentrations of fecal bacteria as well. And the next slide. And so then we've got fecal bacteria being discharged from both the treated effluent there, point 3 there, and also, as you can see now, from the overflow, that 32,500 in the previous slide, just a month later, in fact, that was 350. So that's jumped from 350 to 32,000 there. But then if you look upstream again, where we had numbers of 100 or 200 on this particular gate, they've jumped up to 11, 12,000. And so some of this, in fact, is from upstream CSOs, but also some of this is almost certainly coming from agriculture as well. And then another thing to point out, sorry, Becky, if you can just go back to that one, to point out the figure on the right-hand side there. You can see we've got those high numbers in very close to the sewage works, but there's 2 factors going on here why we have those lower numbers quite not that far downstream. One is because, as I mentioned before, some of the sampling is coming into the plume, so it's artificially high, but also bacteria do die off downstream with time, and so you expect to get decreases from point sources as you go down the river. Next. And then I think this might be the final slide, couple of slides. We've got to think about agriculture. Agriculture will become particularly important after rain events, and particularly after there's been a dry spell of weather, because at that point there can be a buildup of fecal contamination from livestock along beck edges, along stream edges, and on river edges. And when the water level rises, as the river levels rise, this contaminated soil can easily get washed into the watercourses. Next one, Becky. Just 2 to go, I think. And we've got evidence of that from the River Wharfe. These are the concentrations in these small tributaries that come into the river. You see 7,000, 9,000, 7,000. There are some septic tanks in these catchments, but by and large, these are purely agricultural catchments. And so these high numbers are related very much to agricultural impacts. And the next one, and just looking at this in a little bit of detail, you can see this evidence for this now. The red numbers here, this is Ilkley, bottom right-hand corner, and going back up to Bolton Abbey there. You see the numbers in red are the concentrations in the main river. So 300, 1,600, 2,600 coming down into Ilkley, and then that big figure of 55,000, which is below the sewage works. But you see there's also an increase going back up there from 300 to 1,600. This was a day when the CSOs were not spilling. And so these high numbers jump from 300 to 1,600 down to Ilkley are essentially caused by agricultural impacts. And in the red boxes, in the yellow boxes there, you can see those high numbers in the streams coming in. One's coming in through the village actually, but the 3 of the others are coming from agricultural land. So it's coming from agricultural land, but the river is sufficient to actually dilute them to some extent, but not to the extent that they actually minimize the amount coming from agriculture. It's the agricultural source that makes that increase.
So just to say, folks, as you're testing, you can see why you need the strategy for testing, because you've got to point at what's the impact of the CSOs, what's the impact of agri, it's worth doing ranges of conditions, ranges of places, so you can build the picture. So what we found is that overall, even in our upstream in the first site where the place the low, overall, it wasn't the agriculture that tipped us into a major problem with the bathing status. It was, we could sort of keep it below the 900, 1,000 CFUs, but once we got human sewage added into it, it always tipped it. And so that's, you could start building the picture and the story, which is, yes, it's part of it, but the major tip here is from sewage. And that's the bit that I think we have to, it's by doing this type of work, you can start to do it. The other thing, Rick, I don't know if you need to say, is that we do know that Yorkshire Water's done DNA sampling, but we haven't seen the results.
So that's the last slide, which is this is the Addingham one. So the final point I was just going to make was that upstream of Ilkley, there in certain conditions when it's even wetter, then the Addingham pumping station discharges, and this also then sends a slug of dirty water from a sewage works down to Ilkley. So what we find at the Ilkley bathing water at any particular point depends very, very much on weather conditions and where you are with respect to these different point sources. But certainly downstream of Ilkley, it's a sewage works issue. Upstream, it's a combination of the two. And the question that, so to answer the question, if we can answer the question, is you can begin to put together the sources by this kind of, I won't say it's clever in particular, but by careful sampling in different weather conditions. So we've been able to show conclusively that we have CSO discharges that cause high concentrations upstream, and also certain conditions where it's agriculture. And you just need to carry on sampling in different conditions to start looking for sources and then working out what the dominant sources are in any particular kind of situation. Beyond that, you're then into molecular techniques, into DNA testing, and that kind of that is actually being done. It's done routinely by the Environment Agency, probably also by the water companies. I'm not sure perhaps whether the water companies are doing it or not, but certainly the Environment Agency at bathing water sites do what was called MST, which is microbial source tracking, and they use this qPCR technique to separate out bacteria that are coming from livestock and from people. We don't normally see those data. I haven't seen any from the Environment Agency, but what we've been doing, working with the University of Sheffield, is to use these kinds of techniques to separate out the ruminant from the human sources. We have a report. The only problem is that, in fact, that project was funded by Yorkshire Water, and they're not allowed us to release the results. I've seen the data. I got a copy of it, but I had to, even though I was part of the study, I had to sign a non-disclosure agreement, in fact, to actually see it. So I can't tell you anything about it.
So just to be absolutely clear, everybody, the Ilkley Clean River Group does not take money from Yorkshire Water, and that would be through IWolf. So just be absolutely clear, we don't, because we are obviously in the campaign process. We are very clear. The only way we can have the voice we have is to keep our hands absolutely clean in terms of funding. So I suggest you do the same. So being really clear, certainly from our campaign group, we don't. There's one question here, Rick, about phosphates and nitrates. It says, have you looked into the value of testing phosphates and nitrates? Yeah,
absolutely. In fact, we're only talking about fecal bacteria. We could give an equal webinar, in fact, on nitrates and phosphates. And we've got written reports on nitrates and phosphates. It's very, very clear for people to actually, again, think quite separately about these two issues. Fecal bacteria, human health is one thing. Nitrates and phosphates and ecological health is another thing. So most sewage works discharge a lot of nutrients, that's nitrates and phosphates. Nutrients come from agricultural land in exactly the same way, so we got the same ranges of sources, but it's the phosphorus in particular, in fact, that causes ecological problems in the river. The fecal bacteria cause problems for human health. They don't really cause problems for the ecological health of the river. So it's really important to separate these two out. And it's essentially the phosphorus that's discharged from sewage works in the Ilkley area that causes the main ecological problems for the river.
And Rick, maybe you could have a look through the chat and maybe just put some write the question, any answers that you see in the chat would be really helpful. Just to say, folks, just back to this agriculture, we are really clear. Our campaign was to clean up sewage pollution of our river. It wasn't to clean up agricultural pollution of our river. We think that's the Environment Agency's job, because we are absolutely convinced from our data that is the major source of pollution, and also that we are paying for our sewage to be treated, and that our water companies have been very clear that they had the money over the last 10 years with Ofwat to both maintain our sewage system and to treat our sewage. They absolutely were clear they were doing that, and they weren't. So, you could get very caught up, as I think you can see in this, very caught up in all sorts of issues that are outside your campaign focus. You absolutely have to get clear what your campaign focus is and how you're using how the data helps you both understand that and how you then use it to tell your story. So it is really the Environment Agency's job with the water companies to understand the detail of this. And Rick, as part of IWolf, has been instrumental in helping that. I don't see that for me as a campaign group. I don't think it's our job. So our job is to demonstrate what the problem is in order to hold them to account, in order to get the funding and the processes in place to clean the river up. And someone was saying in the chat, have you secured a reduction in raw sewage discharges? These infrastructure projects are not quick. So it's taken us years to get here. I'm hoping it'll be quicker for everybody else. But we have got spades in the ground to sort out the upstream pollution, i.e. our major raw sewage discharges in wet weather upstream of the sewage works. It's a year-long project to do just that. And that will absolutely eliminate those. And then the current infrastructure project, which is to get spades in the ground by 2026, will reduce the raw sewage discharges down to 10. We think, Rick and I think 3 or 4 in Ilkley would be about right. 10 is definitely better than 140. So it's 80. It's a radical difference. So we're absolutely moving in the right direction. So just to be, so always be clear what you're looking after. Always be clear this is part of our campaign. You're not the scientist. You're not there to do Environment Agency's job for it. Make sure you deliver their responsibility back to them so that they do the right job. John, would you like to just introduce Woodleigh Impact and the process of applying for the funding, et cetera, and Rick can type away in the chat and answer some of those tech questions.
Yeah, sure. Thanks, Becky. Lot of useful information there for everyone to take in. Hopefully, I'll give you a bit more in a minute. But just to say something, just to introduce Woodleigh. We're a very small charitable foundation. Only 2 members of staff. I'm one of them. I work 2 days a week. Just to give you an idea of scale. We're very, very focused on impact. So any money we spend, we want to see what's going to be the outcome of this. And I mean, here we're looking obviously at eliminating sewage discharges or other pollution of rivers. So we want to, in assessing applications, that's what we're going to look at. How's it going to lead to that? We love working with small organisations and community groups because we think that's really effective. So that's one of the reasons we're here. We're keen where we can, at the time available, to build relationships with those organisations. And the other thing is, because we're small, we can be quite agile and responsive. And if we realise that funding's needed for something slightly different, we don't have to look at our corporate plan and say, oh, we only said we'd spend this much on that this year. We can, if we get masses of really good applications, then there's the potential to say, actually, maybe we're going to spend a bit more on this than we thought we were going to. So there's a bit of flexibility there. We've been looking at rivers for about 6 months now, and this all started when the sea's getting a lot of attention, sewage pollution in the sea, but not so much in rivers in the press. And since then, everything's taken off, and we're getting a lot of attention. Thanks mostly to some of the people here. So the timing was good because we're kind of we were mobilised, ready to start looking at it. There's 3 basic things we're hoping to fund in the rivers area. One is this bacterial testing fund that you'll have hopefully seen the application form for. Another one that we're slightly earlier stages with is phosphates and nitrates. So those of you who are interested in phosphates and nitrates, watch this space. We're talking to people who are running different systems to try and establish which is the most efficient way to do it. And once we've established that, we'll look at what support we might be able to provide for that. And then the third thing is support with actual campaigning. I mean, Becky's mentioned the importance of campaigning. The whole issue's riding a big wave at the moment. We want to make sure it carries on riding that wave and doesn't peak, and people get bored of hearing that the rivers are full of shit and just go, oh, well, that's how it is, and it all dies off. We need to keep that momentum going. So we're going to be looking at that as well. If people have ideas or thoughts about what support for campaigns would be most useful to community groups, then feel free to either email me or mention it in the chat. So yeah, just want to say something about testing. So obviously, as Becky said, testing is important, and it tells you fundamentally what's going on. But the purpose of it is either to engage the community, to fuel the campaign, and basically, in the end of the day, to deliver change. So you're not testing just to find out what's going on. You're testing to get a positive outcome. The application form, I'd urge you, before you even look at the application form, just to take a step back at the moment. The starting point is not how much money you're trying to get or what testing you're trying to do. It's what change you're trying to achieve and what needs to happen to bring about that change. And if you've thought that through, who are the decision makers? Who do they listen to? What do they notice? Who are your allies? What evidence do you need? Think about all these questions. And then you kind of start to come up with your campaign objectives, which I think is the same as what Becky was referring to as focus earlier. So your focus or your objectives, get them down on the form. I think one of the other most important questions on the form is what actions you plan to take once you have your test results. So put some thought into that one. Other than that, I think the form is fairly self-explanatory. There's a question there or a tick box for genetic testing. Most of you can just ignore that. There are 1 or 2 groups who we've been talking to about individually where you've already done quite a bit of testing on your rivers, and that might be appropriate for you, but it's slightly more complex, so it's something that you shouldn't go for unless you're clear that's what you need to do.
It's like stage 2 of water testing. Get the basics done, then advance.
Exactly. Yeah. So Rick mentioned that we'll provide details of which labs to use and how to go about that. I was hoping to have that all sorted by today, but various people have been on holiday, and we're still in discussions with 2 separate labs. I think you've seen mention of I think it's in the protocol, which most of you have seen. There's a number of tests that you have to do to make it worthwhile on the same day. I think we've succeeded in getting that lifted, so you could be able to send in 1 sample for the price of 1 sample if all you're needing to do is to sample at one particular location. So that's good news from everybody's point of view. What it may come down to in terms of which lab we use is that there's one lab where you can they'll arrange a courier to take the samples. There's another lab which ALS, who the Ilkley group use. They have a series of drop-off sites around the country. So, for example, from Ilkley, you'd be taking your samples to Wakefield. From Lancaster or South Cumbria, you'd be taking them to either Carlisle or Preston. So there's a bit more of a commitment involved in that, but on the other hand, that might enable us to fund slightly more groups. So we're going to, once we've got final prices from both labs, then we're going to look at that. So the deadline for applications is the 1st of May. We'll aim to take decisions pretty quickly after that. It is competitive, obviously. There's probably more groups want the money than we'll be able to fund, but as I said, if we get lots of really good applications, then we can go back to the trustees and say, how about funding, putting a bit more funding into this. So that's kind of how it is, and I'm happy to answer any questions.
Great, thanks John. Just, it's really interesting to look at the chat. You know, there's everyone's got slightly different conditions they're dealing with, so we're not anti-agri versus whatever. It's just what's your, be clear what your campaign strategy is, be clear what you're trying to find out. We're here to help, to help you get what you need to achieve and to secure clean rivers in whatever way. Every river has a different topography, it has different environments, and we absolutely want to support everybody that's trying to do the right job and cleaning up rivers across the country. So just because we're giving Ilkley as an example, just to demonstrate it, but it's not the solution for everybody the way we've gone about it. Anybody want to question for Rick? Does anyone test for soaps and detergents? You can unmute Rick on this one.
I had asked a question about, but from what you said, Becky, you probably haven't done anything about this. Have you done any testing to prove that it is human E. coli and not agricultural? I mean, I know it's possible to tissue type and do very complex and expensive testing of the E. coli, but is there a simple test that one can differentiate?
So just before Rick gets into the detail of this, I think it's going back to, just remember we're local people campaigning rather than that we're all deep scientists. So I think just to be clear, have you done enough to support your campaign to prove what you need to, and then for you to ask the agencies, the water companies, to do their part? So one thing we're always trying to do is walk this fine line, which is what is it that local people should and could do through citizen science to turn the heat up, to get the agenda, to demonstrate, to ask questions, and what is it for other people to do? So I think, Peter, always just be clear, is this something that it's somebody else's job to do, and you're going to really push them to do it by making it really difficult for them to walk away from the problem. So that's the first thing. And the second thing is have you got enough to make a good enough case? And then there's the final thing, nobody will do anything, do we have to step in? And I think just being really clear where you are on that trajectory. And then Rick, just around the...
Well, I mean, it is really quite important, and it's very important for the water companies. And the water companies will want to actually suggest it's agriculture that's the source of the problem, and to some extent, perhaps vice versa. The issue is it's not easy, in fact, to do for citizen science to get involved in it, really. It's something that we've been discussing with John from Woodleigh about the extent to which it might be possible for citizen scientists to actually collect samples. But it's far more complicated than just taking a water sample for E. coli and sending that off to a lab and getting some numbers. It's really very, very important to actually be able to, filter the samples on site in sterile conditions and get them off to an expert lab. And of course, it's not cheap. But it is possible. This is what we've been doing. I think I mentioned this. This is what we've been doing with Sheffield University with some of our samples. And as I say, I had to sign a non-disclosure agreement, so I can't tell you too much about it. But it is very possible by looking at different species of bacteria to identify bacteria that come from cattle, from bacteria that come from humans. And the Environment Agency do this routinely in a thing called microbial source tracking. But they'll only do that, of course, at designated bathing water sites. So it's the chicken and egg sort of problem in a sense, really.
Yeah.
I think this is watch this space. But one of the things I should stress is that what's really most interesting, and something that we're going to be doing on the wharf in Ilkley this coming year, we're going to be working with the Environment Agency and taking the samples that they actually sample for statutory purposes, where they're doing just E. coli and IE, and we can actually then look at the full spectrum of all the different pathogens in that water sample using next generation sequencing. And so there are two issues. There's one is, where does it come from? Is it cattle or people? That is very possible to do that. But the second thing is, E. coli, this might be surprising. E. coli is only a small component of the actual bacterial community in the water. There are many other bacteria, some of which are benign, but a lot of which, in fact, are pathogenic as well. And so the critical thing is E. coli, is it used as an indicator of fecal pollution? Is it a good indicator? Are there some things in there which are very nasty that actually E. coli is not correctly indicating? And that's what we want to look at. What other kind of viruses, bacteria, protozoa are actually in the water samples there? And so the plan this summer is, without using any Yorkshire Water funding, which is a critical bit, is to take the statutory samples that are being collected by the Environment Agency from our bathing water site, get those to the lab in Sheffield, and look at the full range of hundreds of different bacterial species that actually occur in those samples, and see which one of those are dangerous, and the extent to which, in fact, E. coli is a good indicator of their concentration. So, I mean, that's the next thing to do.
I don't want to scare off those of you that are at the earlier stages of this. And, so back to the strategy, which is, we really want the agencies to do their job. And so we're turning the heat up to it. Getting bathing status is to get the agencies to do their job. That's why we apply for it, not because we want loads of people swimming in the river. It's because we want to be able to get testing, and we want to be able to get everybody's interest in testing in order to find out what's going on. So the pattern that we've chosen is, do your citizen science, find what's going on around here. Use that as a way of turning up the heat and the outrage in local people.
Yeah.
Use that to get bathing status because people are horrified. Use that to then get the agencies to do their job. Do you see what I mean? It's the steps to the campaign strategy that really matter here. If we're not careful, you go down a rabbit hole of getting to really deep science without taking the community with you or getting what you need to do. So these have to be absolutely twinned. And the second piece is that the further down the route you get, the more it really matters to have a good academic with you. This is not something you can do on your own if you're people like me. We're lucky to have Rick. But the last thing is that some of this stuff is replicable. Once Rick has done this for the wharf, rivers like the wharf are going to be like this. So you don't really need to do it on every other river that's like the Wharfe. You would absolutely need to do it down south because you've got completely different conditions. But you don't need to do it on rivers like the Wharfe because we've sort of mapped the picture. It will be the same. So that's the other thing that really matters, I think, when you're doing this. Let's just take a couple of questions. Stephen, you've got your hand up.
Thanks. On the River Tyne, we get all sorts of pollution, like everywhere, but we're also seeing a lot of foam. And of course, that's a natural organic process. You see it on clean Scottish rivers and so on. But the kinds of foam we see just doesn't look really like a peaty Scottish river. And there is a rumour locally that there's a lot of washing machines and a lot of water pumped in from a new housing estate. Do you monitor soap, detergents, that sort of thing? Does anyone, is that a possibility?
It is. I mean, the first thing to look at, as you suggest, in fact, is actually natural causes, in fact, from organic acids coming off peaty landscapes. But it could quite well be that you've got some detergents and soaps in there, in fact, coming either from households or from industry. That's something, in fact, to alert the Environment Agency to. And record that as a report that as an incident. Every time you see something that is not normal and not to be expected, just get onto that Environment Agency hotline and just keep reporting it, in fact, and get them to come in and actually take those samples. It shouldn't be coming from a new housing estate because normally if you would actually get detergents coming from washing powders and washing liquids, it's because of a misconnection. And misconnections, not normally actually, you shouldn't expect to have a misconnection from new housing, but you do get misconnections which actually can bring detergents into the system.
It's quite a handy one because we've certainly found, we've pointed Yorkshire Water to areas including Bradford County. I mean, we've gone around the houses again on the misconnection stuff. We had all sorts we found in some of our tributaries and becks going into our bathing site, and it was Rick and the team's testing that demonstrated it, and our visual, Stephen, that demonstrated what the problem was and really held them to account to go and investigate it because they weren't keen to. I mean, none of these people walk happily towards this problem. You are
that stream was called Spicy Beck. Great name.
Not Spicy.
Yeah. I mean, absolutely. We've reported various things and you get, I'll pop down in 2 or 3 days.
Yeah, it's good. Pictures, media, a bit of testing. And I think one other thing that Sheila's just pointed out, which is the times of the labs and who can volunteer. I mean, you saw the pictures of the people that did the volunteering. They are of a certain age and a type. Because you'll find it, you need your retired community or your non-working community for some of this work because it's during school hours and stuff. So it's daytime work. You have to garnish and gather whoever you can and recognize that it's done in school hours, in work hours, this work. Absolutely. Folks, we got any final questions before we finish? Because we will share the record. Sorry, my family, go ahead.
I must apologize for joining you late. Something cropped up. But my thing is, I'm looking at the stream that goes through the woods from Skipton Woods, and there's a sewage works that's just above the woods. And one of the things I mentioned to Rick was I want to test above the sewage works and below the sewage works. But in view of what you've just said, I know the new housing estate on which I live, there is an outfall from that also into this particular stream.
It sounds like, since you're very local, you could have a nice one-to-one chat with Rick about that.
Yes, I'll do that with
that outfall will be surface water probably, my family.
Is it? Okay.
Yeah. Get your strategy together and that sounds good. Anything else? Anybody else? Before I just want to give Kirsty a little moment. Yeah, Diane, go on.
Yes, just wondered whether or not it's possible to ask Rick questions subsequent to this session.
Yeah, absolutely. Please send me emails. I probably haven't. I've been difficulty for me to type on the chat because I'm using my iPad and it's very awkward, in fact, really. So anybody who's asked questions and I haven't responded to them, just send me an email. That's no problem at all.
You send it to the Ilkley Clean River Group or just on the Eventbrite or whatever. We'll get everything to Rick and we'll collate it all and send it around to everybody. It's always good to have everything together. I think that was really good to see. Kirsty, do you want to just say hello from Surfers Against Sewage just so they know who you are?
Hi, everyone. I'm the Community Water Quality Officer at SAS. I support communities to apply for bathing water inland locations. I know some of you already, so good to see you. Good to see new faces as well. We've also got Eve on the call as well, who's a research and science officer, who's got lots of water quality testing experience as well from personal and professional point of view. So yeah.
Thanks very much. So it's lovely to see. I mean, I find that we come up with good ideas on these, and then we say to Kirsty, can Surfers Against Sewage do this? And they mostly say yes. So collating resources, the answer is yes, which is fabulous. You want support for bathing status, Kirsty can help you along as we can. And then finally, just one thing before we go, we've got something, Jennifer, you asked about, you know, where to sample. I think there's just a whole common sense approach to this, which is you can see where shit is going in rivers because it turns it foul and brown. And so start there. So where people are using rivers, where stuff is going in rivers, and then start walking upstream of the tributaries and then starting to look. So it's, you know, just really common sense approach. You can smell it, you can see it. That's the place to start. And then you want to say, what about further upstream? Are the things that we can't smell and see? You know, I'm walking along the riverbank. I can see a gully. I can see something going in. Has that got sewage in it? Test. The only way you'll know is to test. So there's the bleeding obvious places. And then there's working upstream of those to say, just have a look and start testing any sources that are going into the river to find out what's going on. It's a good way of knowing. So you can get your own map. All right, folks, we're at the very end, I think. Can you record this externally? I'm happy. John, it's your party. Are you happy? Rick, are you happy for this to be shared?
Yep.
Yeah, fine by me. Yeah.
I'll stick it on our website too. And then it's everywhere. Is that all right, folks? Lovely to see you. Thanks ever so much for joining us. It is completely marvelous to have so many groups that want to do this. And this is absolutely going to be an election issue next year. So get testing, get your data up, share it with all of us. Let's see what stories and pictures we can generate. Thanks ever so much, everybody. Have a lovely evening.
Thank you. Bye-bye.
We just